Hi everyone and welcome to class. So today I'm going to start a new topic on classes and objects. And so up to now we're working with Python's built-in data types, like for example lists, dictionaries, tuples, and so on, right? Now, what if none of these data types fit what we want to define or what we want to work on? So, for example, what if we want to define a new data type, for example, for a student, for a class, or for a minion? So how many of you have watched Despicable Me? I think I've asked this question before, but let's see if the number of people watched the movie increased. How many of you have watched Despicable Me? Okay, great. I love this class. So you should know the minions. And so let's say we want to, for example, define our own data type called minion, right? And we want to see how we can actually do that. So let's say this is our new data type minion, which has some properties. For example, I want to define my minion based on, for example, its name, height, weight, color, and the number of eyes, because, you know, minions can have one eye or two eyes. And they can have also some actions or behaviors. For example, they eat manna, they steal the moon, sleep, they mutated, they were mutated. So if you recall, the whole movie was based on these scientists trying to steal the moon with the help of the minions. And so I use the same example because I like the movie. So minion has some properties, as you see here, and some actions. And this is the structure for the blueprint for defining or creating our new data type. So just like, for example, an architect that for example, has a blueprint to create buildings, to build a new building or a new house, we want to also create a blueprint to create a minion. And so we are not creating an actual minion yet. So for example, we have not created minion Kevin, minion Otto, and so on yet. We just defined what properties each minion should have and what actions they should be able to do. And this blueprint or this structure is what we call in Python as class. Okay, so this is an example of a class. Now, once we have that blueprint, we can create the actual minions or the actual objects of a class. So, for example, we can have minion Kevin with these, for example, properties. We can have minion Stuart, John, and so on. So each of them have different properties. And so each of like these minions are called an object, or they are instances of our class. Now, the process of creating these objects or creating a new instance of a class is called instantiation, right? The process is called instantiation, and each of like these minions that you see here in this slide, each of them are instances of our class with different properties. And now, as I mentioned before, on the left, we have the class blueprint here, in which we define what are the properties and actions of our class. Here, the class name is minion. And on the right, we have several instances of this class called, for example, minion Kevin, minion Stuart, and so on. So this is the core concept of object-oriented programming. So even though object-oriented programming is not in the official syllabus of the course according to the York University course description, but we've included introduction to object-oriented programming because you will have a course, a full course on object-oriented programming later. And we decided to include this subject so that when you start that course, you have some understanding of the concept. And so in the mid-course evaluation survey I collected, in the the beginning of the course, almost the beginning of the course, I asked you to provide feedback on how to engage the class, how can I improve the course. Some of you suggested using iClicker. So I tried to incorporate that. Hopefully it works. So how many of you have used iClicker before? Okay, how many of you have no idea how to use it? Okay, so for those of you who are not familiar with iClicker, you can download the app. You can download the iClicker app, and then you should be able to find the course either by the course code, which is ECS 1015. Some students in my previous class told me they could find it using my name. So before I run this question in iClicker, I'm going to give you some time to have the app installed if you haven't done so. I'm starting the poll, so you should see this question now. What is the main difference between a class and an object? Go, go, go. 20 responses so far. 24. How many of you are in class today? $29, $32. Good. Can I give you 30 more seconds? You've been able to join?
Unfortunately, I want to try to sign in because I don't have any courses to do.
Let's see that. Okay, can I have your phone for a second? Just give me a second to go to this. Sorry. So let's see the results. So the difference between a class and an object, the correct answer is option B. A class is just a blueprint where you have just the structure, you define what the properties and actions are, and then an object is an instance of that class, right? For example, you define the class Minion. So Minion is your class, but so what's happening here? Minion is your class, but for example, if any new instance of that class, yes? You use the same email that you created your account with? We can check in the break time. Yeah. So anyways, I'm still showing the questions on the screen and I'm explaining every question, so it should be good. And then we can go through that in the break time. So this is the correct answer. An object is just an instance of the class, right? For example, Minion, Kevin, Minion, for example, Otto, and so on. So the different minions with different characteristics. Now, so we already had using actually classes the whole time in this course. For example, when we were using a string list and so on, all these data types in Python, they are defined as classes. So these are actually predefined classes in Python. And when you write, for example, so because list is a class, when you define, for example, let's say A as a list, for example, A equal to, for example, 1, 2, 3, 4, 5, so something like this, you are actually instantiating a class. And what would be A then? Is this your class? Is it an object? What is A? What does A represent here? If you have a class list, then A is your object, right? A is a new instance of the class list. And so the process of these creating new instances from the class that you have is called instantiating a class, which you see here the examples. And then you can also manipulate that object. For example, here we define the object A, right, from the class list. And then we can, for example, sort, we can append. So we can basically use all the methods that are defined in the class list. So these are predefined by Python. And today we want to learn how we can define our own classes. For example, if what we want to do doesn't fit into the current, for example, current classes like list and so on, and we want to define our own classes, how we can do that. And so here is how to declare a class. So this is the basic structure of declaring or defining a class. So you just use the keyword class here. So this is the keyword followed by the name of your class. Now, in terms of naming convention, you have to use capitalized word and you don't have to use any underscore. So for example, if you want to define a class with, for example, name, like for example, computer science student. So if you want to define a class with this name, you can't use computer underscore science. So we call this camel case, right? So we have to use this, or for example, we can call it, you can call it upper camel case, or for example, Pascal case, which means you have to write each word capitalized without any underscore. And then within, like underneath this class, we have, so this is your class name. Then we also have several methods and functions, right? What you have in every and each class that you define is this init or dunder init or double underscore init method here. And then you can also have different methods. So let's first see in general what does these methods do. So as I mentioned, every class should have just one self method as its first parameter. You can have more than one parameter. Like the examples here all have only one parameter, but you can have, for example, others like self and some other parameters. Now, self always refer to your current object, and we will cover more about self today. We have also some examples and quizzes. So for now, the important thing is to know the structure when you declare a class. So the structure is a keyword class followed by the name of the class, right? And then you have different methods here. Now, this method is predefined for all classes. So you have to use the dunder init method for all classes. And they also must be indented. Similar to the functions when you define, right? If you don't use the indentation, the proper indentation, you'll get error. The same thing applies here. So for your exam, you have to be careful also with the indentation, especially because for your final exam, you won't have the remark regrade request anymore because of the deadline limitation that we have. All the final grades must be submitted maximum five days after the exam date, which doesn't allow us to provide unfortunately, any accommodation on the regrade request. So you have to be really careful with your final exam, trying to avoid syntax errors and the problems you had with the midterm. Try to avoid those types of issues. And so there is one special rule here that every method must have self as its first parameter. So here we only have self, but if you have any other parameter, always self should be the first. And yeah, let me finish this and then I'll go back to the questions. In terms of naming conventions, they should be all lowercase, separated with underscore. This is about the method, right? So the class itself use the Pascal case, but for the method name, we have to use lowercase separated with underscore. And so the only thing you have to know for the self right now is that self is just referring to that specific object that you want to work on right now. Okay, so that is like this is the current object. This is what self means in just the simplest possible way. Now, what does the parameter self represent inside a method? I just said that. So everyone should answer this. Just want to see who were listening to me. You just mentioned. What does self represent? Does it refer to a class, to a module, to an instance, or file name? So 10 more seconds. Okay, so let's see the results. 88% chose option C, which is the correct option, and then only 12% selected A. So let's see. So this is option C, the instance being created. So self, the question asks what does self represent, right? So as I mentioned, self is just the new object that you want to work on, right? This is your current object. And this is more about the more on declaring a class. So far you have seen that we have this structure with the class keyword, class name, and then some method that I mentioned always have to have the init method first, and then we can have other methods as well, depending on what we want our object to do, right? For example, if we want to define the minions to eat bananas, then we have to define also a banana method, right? And so on. But this one, so this first method must be always this dunder init, and it is used to instantiate the object. What does it mean? It is just creating a new object. For example, in the minion, when we define a minion class, this init method is just instantiating a new minion. For example, minion Kevin, minion Stuart, and so on. So what do you think we need to define? What should be the parameters based on the class blueprint I showed you at the beginning of the class? What do you think should be the parameters defined in the init method? What are the properties that we should define here? Minion properties, right? Because init is just instantiating a new object, right? What is our object? Each minion, right? Because this is a class minion, and each specific minion or each instance of a minion is one object. And then we have to define the properties. What were the properties of the minions? Number of eyes, color, right? Name, weight, height, and so on. So these are what we discussed here, right? So this was our blueprint here. This is our class where we define the properties and actions. These are instances of our class, which are different minions, which are also our objects. Okay, so we are here. Now, these are the other methods. So as I mentioned, you can also define other methods based on the design of your class, based on what you want your object capable to do. For example, here we want the minions to be able to do like these behaviors or these actions. So these are what we define. Who remembers pass? Why do we write pass here? What does it do?
It basically is used to so that way no errors are generated from the code inside.
When you, for example, want to just have the structure of your code and add the rest of the code or more details later, it's like a placeholder, right? It's like, for example, I'm going to add more information later, but just don't give me any error right now. This is what pass does, right? And this is a great functionality in Python. This is Python specific. So let's see this demo here. Demo minion. Okay. So you don't need to know the whole code right now. So far, we have mainly talked about how to declare a new data type or class, right? Which we define here, for example, class minion. And then we always said that the first method should always be the init. Why? Because that's actually a method that is creating new instances of the class, right? For example, in this case, it is creating new minions for us. And then we have, for example, always, as I mentioned, self is the first parameter. Sometimes we have more parameters, but self is always the first. And this is because it is referring to the current object. So we have self, and then we have the properties that we want to define for our minion. For example, minion should have name, which should be a string, height as a float number, weight, float number, number of eyes, color, and so on. And we don't want to return anything right now. And here is what you learned when we covered functions, right? So if you provide the doc string and then the test cases, for example, you can define a minion Kevin with giving the minion these values, right? Kevin, for example, is the name, 150 is the height, 20 is the weight, right? And the number of eyes is 2. And the color we already defined yellow, right? So if I just, let me type this here. Now, how can you access, for example, each specific variable, like, for example, weight, height? You can just type name of your object, for example, here, minion Kevin, right? Which we define here with underscore name. I'll cover more about this underscore, but for now, the only thing you need to know is that this is just to signal, for example, other developers that this is a private variable. And this is because in Python, in contrast to other programming languages that they have, for example, specific keywords like private to define a variable as private, in Python, there is no such thing. And so there are some problems when a variable is private. There are some problems with accessing or, for example, updating them directly, which I'll explain again later. So in order to avoid that, we are just signaling that, okay, this is private variable, and then you have to follow specific ways to access or update that variable values. So, for example, what do you expect? Then it should bring the name Kevin. The same way you can, for example, return the value for the weight, height, weight, and so on. And so this is what is defined here. Then we have this string method, which I explain later in the next slides. This is basically, if you don't define this string method, and then, for example, you try to print minion Kevin, it doesn't print anything. It just returns a strange, for example, value, which is the ID of that object. If you want to return something like, for example, printing minion with this height, name, weight, and so on, you have to define the string method here, which gives self, which is the instance of your object, and return a value, which is a string, because this is what it returns, right? So this is a string. And so we defined also, I'm going to explain equality and so on later. So these are the methods we explain later. What else we have here? We have, for example, eat banana method, right? So what does it method do? Just feeding the minion with bananas. So for example, what do we want to happen if we feed minions with bananas? So we want the minion gaining 0.2 pounds for each banana they eat, but the total weight should not exceed 30 pounds. The minion will be full after eating bananas, and the precondition is that the number of bananas should be integer greater than 0, right? So based on like this description, so you have here, for example, you can define the weight, which is basically the original weight plus this amount, because we want the minion to get this extra pound after eating the bananas, multiplied by number of bananas, of course, because this is the weight for eating each bananas. And then it shouldn't exceed, for example, the 30 pounds. So the weight should be the minimum of the weight of 30. So whatever is the minimum, because we don't want to exceed 30. And so it's full at the beginning is true. Other method that we define is stealing the moon. For example, what does this method do? This is required to execute the task of stealing the moon. So it's just a bool. We can just define a boolean here and returning, for example, full and so on, and so on. So I'm skipping these parts because these are not specifically relevant to the topic. The only thing that you need to know specifically in terms of classes and objects is how to declare a class, which is this structure, right? This structure here. And then the init method that is always your all classes start with this method, learning about the self, and if you need, for example, other parameters. And that's it. And the important things about these two methods that I'm explaining later. So I'm going to cover this very soon. Yeah.
So basically, the Meiying Qin basically 150 before it stopped.
Sorry?
Basically, a minion, if I understand, can 150 bananas before it stopped because 0 pounds to begin with.
They can, sorry, what?
How many pounds can you start with? I'm a little curious.
How many pounds they can start with? What should be their weight? Anything, as long as it's less than 30 pounds.
Well, hypothetically, if it starts with 0 pounds for each any bananas, they can eat 150 bananas before having to stop, I think. So,
they already, when we instantiated the class, each instance of the class, we already defined their weight, right? So they start with some specific weight. So each minion, for example, minion Kevin 1, this is the weight of minion Kevin 1, and this is the weight of minion Kevin 2, which is the same weight here, and so on. So there could be different weights. Okay. So do you see any problem with directly accessing and updating the instance variables? What do I mean by instance variables? For example, here, we define minion Kevin from the class minion, right? So this is a new object from the class minion. And we have, for example, name Kevin, weight 150 pound, height and weight 20 pound, and number of eyes, right? Now, if you want to change the weight to, for example, 25.3, if you write this, what do you think will happen? Do you get any error? You won't. So you will not get any error. But there is a problem with accessing or writing directly here. And that is because, for example, a user may, or you may mistakenly provide invalid input, right? For example, for a weight, you can provide a string. For name, you may provide integer, right? So for example, what if for the weight, you just give it like integer instead of float, or for example, a very long number, or a string, or a Boolean, or anything that is just not accepted. Python doesn't give you an error, which is the problem. This is kind of a logical error, right? Because it doesn't throw any error that you understand, but this is not acceptable. So the solution is using getter and setter. So what is the difference? Getter is just to read the value of a private variable. Our private variables here are, for example, what we define with underscore, right? For example, weight, height, and so on. And setter is just for the writing the value of a private variable. And this is because, so this is the problem, that most instance variables are intended to be private and shouldn't be accessed or modified directly. So shouldn't be accessed or modified like this because of the problem I just mentioned. So in Python, because it doesn't show you any error for that, in order to address this, we have to use getter and setter. In other languages, for example, in Java or C++, this problem doesn't exist because you can enforce privacy using the private keyword, for example, private. But you don't have that here in Python. And so let me see, show you how to use that. Do we have? Okay, I thought I had a, yeah. So we have a demo later, but before that, let me run these questions. So why is self weight underscore weight written with an underscore? So why do we do this? Ten responses so far. That's good. Okay, give you 10 more seconds. 38 responses so far. 40 responses, that's good. 3, 2, 1. Okay, let's finish this. See the results. 80% 83% selected the correct answer, which is option C, and a few of you selected other options. So as I mentioned before, this underscore is just because we don't have a direct way of explicitly mentioning, for example, if a variable is private in Python. This is a way to, for example, signal other developers that, hey, this is private, and then you don't have to access it directly. Use, for example, getter and setter instead, right? And so the correct answer is C. Do you like using iClicker? Yes? Yeah? Okay. You're very quiet. iClicker question 4. So when you are very quiet, it seems dangerous. I'm not sure if you're very engaged. So we have this class M with these two methods, and we want to see what does this print. So this is your setter here, where you actually can write, right? You cannot see the question?
No.
How about now? Okay, sorry, my mistake. Make some noise. Okay, 20 responses so far. $30. I'll give you 10 more seconds. Okay. So the correct answer is option B. So let's see how many. 57% chose the correct answer. 19% chose A. 17% chose D. And yeah, it makes sense. And then some of you chose option C. I don't know why C. So the correct answer is B, and it's because the setter has this condition if V is positive, right? So it rejects the negative value, and the original value remains. What was the original value? Here we passed 5. What is self here? M is passed to the self, right? Because this is the new object you created from the class M, right? This is like an instantiating a new instance of your class M. This is your object. This is the value you pass here to W. And then here at this point, because the condition doesn't meet, right? So it doesn't write anything here. And so the original value remains. So when you just print this, then you still get 5. That's why the correct answer is B. And next. So just want to show you the demo of getter and setter. So in your code, you can see it here. So as you see, we have, for example, get name, right? Get weight and set weight. So for example, we can set the weight of the minion. So instead of directly changing the way that I did in the, I actually didn't do what we can do. So for example, instead of directly changing the weight like this that we see here, so if you do this in an interactive mode, you won't get any error. But as I said, there are problems with this. And so the recommended way is using setter, for example, if you want to write. And this is the way to do it. So, okay. Now we also have, if you check the same file, the same Python file in demo minion, you will see that we have another special method, dunder string or str. Now, what happens if we didn't define it? I want to show you what is the point of like including this and what happens if we don't. So if you don't have that string method and you, for example, define a new object, for example, minion Kevin from the class minion with these, for example, properties, then if you print minion Kevin, it just shows you this weird result. Just, for example, minion object at some address in the memory, right? And this is because we didn't define how to represent that string. So Python let us actually to define this ourselves, which is included here. So if you don't define this, let me comment this first. So I'm actually commenting this part. Okay, Control I. And now okay. I'm not sure if I can save. Yes, I could. And then, so if I just find the same minion Kevin to save time, let me just use the same minion here, right? We define this. And then if I just print, let's say, minion Kevin, so if I print this, see what happens. It just returns minion object at some address, right? It doesn't show me the actual minion Kevin. It doesn't represent that, for example, minion Kevin height is this, minion Kevin weight is this, what are the number of eyes and so on. So how can we address this? Using the string method here. So here I defined how I want to actually represent this, right? So if you just save this and then print the same thing. Okay, I'll have to think. Sometimes it doesn't work this way. Okay, so let's define this again. Now, if I print minion Kevin, it should actually show me what I defined at this line, what I defined here, right? I said it should return when I have a self refer to this object, which is minion Kevin here, right? I wanted to return a string, which I defined here. For example, self get name, right? Get the height, weight, and so on. So as you see, now I see minion Kevin, height is, for example, 150 centimeter, weight is 20 pounds. It has 2 eyes and it is yellow, right? And this is what I specifically mentioned here, right? So this is what is defined here. And so this is the whole point of a string method here. And so next question, what does this code print? So I give you only 30 seconds to answer this. It's so easy. Just cover this, right? We have a class robot with the init method inside. Then we create this new object from the class robot, right? So the self here, what is self? Self is R, right? So self is R, ID would be 10. So you have to select what print R represents. Ten more seconds. Okay. So let's see. The correct answer is A. So it returned this object at some memory address the same way I showed you. So in the demo, I showed you if we don't include the string method, right? Python doesn't know how to represent that object, right? So it just show an object in some memory because we didn't show how to represent it. So here is the same thing. So we are creating a new object, which is R, and we pass this value ID to 10 to ID, right? But R is actually our object, right? And we didn't define any string method to represent that string. So we don't know how to show that. So for those of you, let's see how many selected the correct answer. 61% chose option A. 27% chose option B. So B is actually, if you print ID, then would be 10, right? Robot is just your class, right? So when you print R, R is not robot. So this is your class name, and it doesn't return any error. Now, I already showed you what happens if you don't define a string, right? So it just shows minion object at some random address. Now, there is another special method in the same demo file, which is under equal or EQ. Without defining it, if you have, for example, if you define two, for example, minion instances like minion Kevin 1 and minion Kevin 2, even if they have the exact same properties, same number of eyes, same color, same name, and so on, if you compare them using equal, it returns false. Why? What does equal check? Check if they are the same object or not, right? And they are not the same object. They are two different objects. This is minion Kevin 1. This is one object. Minion Kevin 2 is another object. So by default, equal, just check whether they are literally the same object in the memory, which they are not. And so it returns false. Now, what if you wanted to return true? So what changes you have to apply so that minion Kevin 1, when you compare it to minion Kevin 2, if they have the same properties, it returns true? We can define it ourselves. So you can customize it however you like. So you can define, for example, equal. You can define equality based on, for example, whether only their names are the same, whether two minions have the same name, even if other properties are not the same. You can define it, for example, only if all the properties are the same. For example, only if name, weight, height, and everything is the same, and so on. So in this demo here, what did I do? So here is the equality method I'm talking about, right? So here you return self get name and self get weight. So this function, which gives self and minion, and return a boolean. So it is just returning either true or false. It returns true if two minions share the same name and weight. This is how I defined it. So you can have it only, for example, checking for the names or any other properties. So because I defined it based on comparison, based on the name and the weight, so here I should define, first of all, I should return get name and get weight, right? And then I should define get name and get weight, and so on. So it depends on what you want it to do. And then you can customize it however you like. So if you want to, like, for example, compare them only based on the name, then you can get rid of this part. Okay, so you can only check them based on their name. And so I think this was the height. This is the weight. So yeah, you can try with that. For example, you can change minion Kevin to weight. And also maybe their name, and then try with these two, once with get name and weight, once with only get name, and see how they differ. And okay, question 6, what does this code print? 8 responses so far. This is easy. So you have, once you are comparing A to B, so A equal B, the next time B equal A. So the difference is which one. For example, when you write A equal B. Okay, if you write, for example, A equal B versus if you write B equal A, how do they differ? So, for example, what is self in this case? What is self in this case? And, for example, if here self is A or if it is B, what would be self underscore N would be? So, let's see. So 31 responded. So let's see the results. We have, so the correct answer is B. So the first one, A equal B, return true. But if you type B equal A, return false. So the correct answer is B. And let me explain why. So first, when you have this A equal B, can you tell me what would be the self? So now you're creating A, right? Which is an object. So this is passed to the self, right? Always the object on the left, the one on the left is your self. For example, here the self would be A, but if you type B equal A, the self would be B. And that is important. Why? Because, for example, in the first case, A equal B, self is A. Now, if self is A, self underscore N would be A underscore N, right? And what would be A underscore N? So for the A, as you see here, I think you passed 10, right? C 10, right? So the value, so this is your self, this is the value, right? So the value would be 10. Now, when you are comparing the equality, so this is the function comparing the equality, right? In this function, you are returning self underscore N, comparing it with this, and all representing just the other, right? So in this case, you have 10 comparing to, what would be the value of B underscore 10? Underscore N? What is the value of B then? 5, right? So you see it here. You pass 5 here, right? Then this would be 5 multiplied by 2, right? So 10 equal to 10. Is that true or false? True. So this is the first one. So the important thing here is when you type A equal B, the self is A. And when self is A, so self underscore N, your N would be 10 here, right? And so on. So the same way, who can explain B equal to 8? Yes. Yeah, then it would be 5 equal 10 multiplied 2, right? Because in this case, self is B, right? And then you have 5 equal 10 multiplied by 2, which is 20. Now, is 5 equal to 20? No. So this is false. So the final result would be true, false. And so when you want to define to recognize the self is always the object that is on the left side of your equal operator. So for example, when you have A equal B, which one is on the left? A. So A is the self. And then here, which one is on the left? B. So B is yourself. And next we have file. So let's see how the file system works. So your computer stores files in the file system, which is basically a hierarchy of the folders and their subfolders on the hard drive, as you see here. So unlike variables in Python, which disappear when your program ends, files are stored permanently. And so if, for example, I save a Python file lab1 here, right? Inside that, I may have, for example, so you see, for example, I have Python folder lab1 to access the lab1.py file. And then this just tree structure help you find the file later. So this is just important because later, if you want to read or write from file, you want to access the path, right? So these are the terms that you have to know, like I for input, O for output. And input means reading data from the file. Output means writing data out of your program or sending data out of your program. So file input reading the file and file output writing content to the file. So how do we open a file in Python? Easy, just using this open keyword here. And then in the parentheses, you have the name of the file, and you have to specify what is the mode. Is it a read mode, write mode, or append mode? For example, if you just want to read the file, you open it in the read file. If you want to write, you can use W. And if you want to keep, because W overwrite the original content. So if you want to keep that content and add something or write something more, then you can use append or A. So here are just the three things you have to know here. So demo underline file is just the name of your object here, or file name. So this return an object which is bound to a variable. So Python creates a variable for this object. And then here you specify the name of your file. So this is using, you can use either absolute path or relative path. So the difference between, most of the time we use relative path, which means, for example, the path relevant to where your file actually is. For example, if your Python file is in the same directory or path where your, for example, text file, demo text file is, right? Then you can just write it as we wrote here. And otherwise, you can give the full path. And so as you see here, relative path is the path that is relative to where you are now. For example, demo text and, for example, your Python file here, they are, if they are in the same folder, same directory, then you can just use the demo text as I used here. So it means that you have that text file in the same folder as your Python file. And if the file is somewhere else, then you can reach it, but then there are some other methods which I provided these optional links here. You can also use absolute path, which is the entire path. For example, if you have Windows, this is how it looks like. And so for simple projects, we just recommend using the relative path. And this is just repeated slide. So the mode description, so we are explaining the mode here, could be R, W, or A, right? So this is, for example, it means that we open the file only for read. This means we open it for write, right? And the important thing here is that if the file exists, let's say I have a file including something with some text. If you write anything, then it overwrite that. So you have to be careful with that. If you want to keep the original content, you may want to use A. So with this, the existing content will not be overwritten. Okay. There are 4 different ways to read the text file. Now, if, for example, you can have read line, you can have a for loop. You can just basically read, use a for loop to just go over each line, right? Another one is read lines and read. So there are just some differences between these based on, for example, if you want to use, for example, sorry, can you please stop that? So depending on whether you want to read line by line or for example, do you need help with that? Can you just mute that? So for example, if you want to read one line at a time, so if you want to read, for example, line by line, you can use readline. So this is good when you want to, for example, a full control, for example, stopping early, or if you want to skipping some lines, this is, for example, useful. The most common and cleanest way to read file is using the for loop, which is the second method here. So you can use this just when you want to process every line. And then we have read lines and read. So this one return a list of all lines. So where is that one useful? Because you are returning, you read it and you store it in a list. So you can also get you can use all the benefits of list, right? For example, you can use the methods that are available for a list, like sorting, for example, indexing, and things like that. You can use those methods as well. So, for example, if you want to sort the lines or index the lines and things like that. And then we have the read method. So read is just reading the entire file and put it as a string. So this is also useful if you, for example, want to do some text analysis to process the full text, then you may want to just use the read instead of read lines, just reading the whole content at once. So let's, unfortunately, the demo doesn't work here. I was trying that on this computer. On your computer, for sure, it works. On my laptop also works, but because we are short in time, I'm just showing you the file. There are some path issues here. Okay, so the file input, I guess, is here. So I'm just going to show you explaining them. So as I mentioned, for example, the first method is readline. So you open, for example, the file in R mode, which is the read mode, right? So you write open, name of the file and R mode. Then we have several methods to do that, right? Method one was readline. As I mentioned, it is good if you want to have full control over, for example, each line, if you want to skip some lines and so on. So you can use, for example, readline like this, right? And then you can try with this, for example, if you don't try it once, for example, without using a strip and with a strip. Unfortunately, it doesn't work on this computer, but if you run it at home and you have the demo text file in the same directory, which I already included for you in the same directory, you should be able to run this. And then this just read one line at a time, and this strip just get rid of the spaces at the end. And then you have to remember to close the file because Python automatically doesn't do it. You have to open, you have to close it. Then the second method was using for loop. You just write a for loop to go over each line. So this is the simplest and cleanest way to write it. And method 3, which is this fine, is read lines. So as I mentioned, this just store the lines in a list, which is useful, for example, if you want to get, you want to use, for example, the list methods, like, for example, stored and so on. And then this one, just if you want to process the whole text at once and do some text processing, you can just use read instead of read line, right? And you always, as always, you have to also remember to close it. I also give you an alternative. Instead of writing close, you can just use with open, which tell Python to automatically close the file, even if you don't explicitly mention that. So this is I think maybe the last question. Assuming our demo text file containing this text. So we have a text file with this text. We want to see what does this code print. So I think 30 seconds for this question is enough. It's very simple. "12 responses so far, 14, 15. So you have to just check the condition here, right? So we go over each line, and then if line strip starts with B, and you know what the strip does, right? If it starts with B, then we print the line. So you have to see if it is actually, which one it is printed here. Okay, so let's end this. 97% chose the correct answer, which is option A. And because, sorry, let me get rid of this. Why is that? Because the condition is if it starts with B, right? So if we have, for example, a word starting with B, like banana, blueberry, right? Then we type it, we print it. And whenever we open a file in Python, we must close it right after it. As I mentioned, Python doesn't automatically close the files. And why do we need to close them? Why don't we just leave them open? What is the problem with that? Yeah, that is the very important problem because as you see here, multiple users or even multiple programs may access the same file. Now you may, for example, while some person are reading the file, the same person may change the file or update the file, write the file, or for example, several programs accessing the same file may cause unintended or unpredictable behavior, right? And another problem is that it is just not efficient in terms of the memory, right? And so a better way or recommended way is just to type with open. If you just type with open, then it automatically, Python knows that it automatically closes the file, even if you don't write it. It's just cleaner and safer way in case you forget. And always remember the indentation here. So the last question. So this is just a demo before I go to the last question. Let me run this demo here. So as I mentioned, it's better to write with open, right? So that it automatically closes the file after you finished your writing or whatever you're doing here. And then we, for example, want to write this. So if I have already some text in demo 2 text, which is this file. So let me show you the file. Sorry, this is the file, right? So here is a test. So this is what is written in this file. Now, if you run this and you write, I want to write this very, very long string or whatever you write here, then this will be overwritten. It means that the content that was already written in the original file is deleted and this will be written. How can you keep both? A, right? Append. And I'm not running this because I have some access issues here. And the last question, why is with open recommended? I just explained this. So everyone should answer this. Should I consider a penalty for those who choose the wrong answer? No, I'm not. I'm kidding. Okay. So the correct answer is B. So let's check the results. 70% selected the correct answer. Few of you selected option C and D. And so as I mentioned, we use with open because it automatically closes the file. Otherwise, you have to use close, and you may forget. So this is just cleaner and more efficient way to write it. So next is just your puzzles for the next week. Also prepare the Kahoot game, including, I think, maybe 10 questions. So let's play that.